Processing is another software environment that we're going to use in this class. It was originally built on top of the Java language and was originally designed for students and folks who are involved in visual arts to actually start programming and using their computers. So what it's going to allow us to do is provide a much richer environment than just the serial monitor to display the kind of data that we're capturing from our Arduino. It also ultimately allows you to interact with your keyboard and mouse, which you could ultimately use for controlling your Arduino. Now the processing software environment looks a lot like the Arduino IDE that we've been using, and there's a reason for that. Arduino was actually built based on processing and wiring, which you can go to the website and read about. Right? So the one thing you'll notice, or a couple things you'll notice that are different, I only have a run and a stop button here, and you'll notice as I go through some examples that it's actually compiling and checking for compile errors in real time, and you'll see it pop up down here. I also have this black console. I can look at my errors separately over here, but I have my black console down here, and I can really use this very heavily for debugging and trying to figure out what I'm doing with print and printline statements, much like we did with serial.print and serial.println statements on the Arduino. So I'm going to start with the simplest program possible, and that's going to be my hello world. So like the other thing, so you can see automatically it's telling me I'm missing my right curly bracket, so it's already catching that. So you can see I have the same setup function that I do in the Arduino, and in this case I'm just going to print line hello world and run that. And what you'll see is it prints in the console window, hello world. Right? It's only doing that once. Setup, like in the Arduino, is only running through once. But as I mentioned, processing is really focused on this visual environment. So instead of a loop function down here, I have a draw function. And my draw function, much like the loop function on the Arduino, is going to loop through repeatedly. But I'm going to put anything that I want to loop through repeatedly in here. So if I took that same hello world and printed that, or put that in my draw function, ran that, I would get continual hello worlds in my console. But let's do something a little more fun. Let's actually draw something in a window. So I'm going to stop this, and I'm going to go to my processing language reference. So this, once again, like the Arduino reference, is going to be your go-to page for trying to find how to do stuff in processing. So in this case, I'm going to be able to initialize a window by using the size command. And I know that's not terribly intuitive, but that command is going to be specifying the size of my window. And so you can see here, if I scroll down, it will give me some syntax at the bottom here where I'm specifying the width and the height of that window. So we're going to set up a window that's sized 100 by 100, and I'm going to put that in my setup function. I'm going to get rid of this hello world for now. And now I want to set the background color of my window, and I can look for the background command to do that. And background, if I scroll down to syntax, is going to take an RGB value. RGB stands for red, green, and blue. And each of those is going to be an 8-bit number, so from 0 to 255. So if I go back here and use the background function and set, we're at Maryland, so let's use a red window here. So my red value is 255, green is 0, and blue is 0. And if I run that, I'll get a 100 by 100 window that's red. Now let's actually add something to that window. So I can stop processing. And to add something, I'm going to use two very useful commands for setting colors. I'm going to set the fill color of whatever object I'm going to draw. That's once again a red, green, blue value. And I'm going to set the stroke or the outline color, once again, also a red, green, blue value. So in this case, fill, still at Maryland, so let's use yellow for my fill value, and let's do stroke as the same thing. So 255, 0. So yellow in this case is a combination of red and green. Right? And so when I get into my draw command, I want to actually draw an object. So in my case, I want to draw an ellipse, but you can see there are a lot of different shape-related functions in processing. So an ellipse is going to give me a circle. I can also use rectangle to draw a square, or rectangle, triangles, all sorts of interesting things I can draw. So if I go to the ellipse function, I see it takes 4 integer inputs, or 4 float inputs in fact. The x-coordinate and the y-coordinate of the center of the ellipse are a and b. And then C and D are the width and height. So if I want to do a circle, I want those things to be equal. If I go back to my command here, I'm now going to draw an ellipse. I'm going to position that in the center of the screen. So I drew a 100 by 100 window, so I'm going to use 50, 50 as that XY coordinate. And let's say a diameter of 30 for my ellipse. And this should draw in yellow because we've designated the fill and stroke colors as yellow in this case. So if I run that, I see a yellow circle inside my red window. It's about 30 pixels. It's about a third of that 100 pixel height and width for that window. And that's great. I've drawn my first shape. So let's do something a little more interesting. Let's continually increase the size of that circle. So I'm going to declare a variable, circle size. I'm going to initialize that to 0. And when I get into my draw command, I'm going to just continually increase that circle size. So I'll use circle size for the actual diameter of the circle. And then I will increment, so circle size equals circle size plus 1. I could also just use circle size plus plus, kind of like we do in for loops here. And so this should increase that circle size, and this would just keep increasing it indefinitely. So one thing that I'm going to do, I want it to max out at 50. So I'm going to do a little clever programming trick and take that circle size modulo 50. So this percent is a mathematical operator that's a modulo, and in this case that basically means the remainder. So if I have 49 divided by 50, the remainder is 49. If I have 51 divided by 50, the remainder is 1. So you can see I would just restart at 0 again once I get above 50. If I get to 151, circle size will go back to 1 again. So this is just a convenient way to reset this each time. So if I go ahead and run this, I can see that circle growing, but then it actually stopped. So let me see what's going on with that. So I'm going to stop, and I'm going to use that console window to actually print my circle size each time. And so hopefully I will be able to use that to see if I am actually incrementing my circle size correctly. So if I run this, I see it is resetting. So, oh, I just realized what I did. My stroke outline is yellow, so it's just rewriting on top of all of this. So let's go ahead and stop this, and let's go keep with our Maryland theme, and we're going to make the stroke black. So I'm going to go ahead and run this, and now I can see that circle is continuing to increase in size, reset to 0, and increase in size again. Right? But maybe I don't want it to kind of look like this. Maybe I want it to actually reset that circle at 0. And to do that, I basically have to use that background command again, and I'll set it to red. And that will basically redraw the background, wipe out anything that I've already sketched in there each time I go through this draw loop. So if I stop that and run it again, now my circle does exactly what I intended it to do, right? Those were kind of runtime errors that I might have in my software, but now it's doing what I intended to do, and you can really use these print lines in this console window to your advantage in this case. So now I'm going to do something a little different. Instead of increasing the size of the circle, I'm actually going to take a circle and march it across the screen. So now I'm going to create a circle X position variable. I'm going to start it at 0, And now, instead of 50 here, I'm going to use circle X as that X coordinate of the center of my circle. And I'm going to fix my circle size at 5. And then I'm going to increase or increment that circle X value by 10. And in this case, I'll modulo by 100. So I restart at 0 once again once I get to 100. And I'm going to print that coordinate as well. So I'm going to run this. And now I can see that thing racing across the screen. It's racing a little too fast for my taste, so I can actually use a delay here, a lot like we did in the Arduino. I'm going to do half a second after I do each tick here. And I still have that background in there, so it's erasing everything each time. If I want to keep all of those preceding dots, so maybe I'm trying to plot data from my Arduino, then I want to only blank the screen once I get to the end. So a lot like an oscilloscope would do. In order to allow the data to be continually displayed and only blank things at the end, I'm going to get rid of this modulo stuff and do things a slightly different way. So now I'm going to use an if statement to say if circle X is greater than 100, then I want to reset circle X to 0, and I want to do that background command 25500, and I need that close bracket. I'm going to take away this one up here and run this again. So now you can see that yellow dot marching across the screen. Once it gets to the end, it blanks and starts writing again. So this is a really useful way to plot data. I can do something a little more interesting if instead of just controlling the X position, I control the Y position, and I can see how the pixels on my screen are arranged. And what you can see is it's actually marching down as that circle X is increasing. And that's because position 0, 0 is at the top left of my window. So X goes to the right, Y goes down as it increases. So that's a little odd to get used to. We're used to thinking of 0, 0, or the origin at the bottom left. In this case, it's at the top left, and Y increases while you go down.